Now here, one simply supported beam of length L is subjected to a concentrated bending moment M0 at a distance A from the left hand support A. Now what will be the bending moment and shear force diagram? So let us draw the shear force and bending moment diagram. First of all, we have to calculate the support reactions. So this is the beam. Say this is the beam, and let us consider reaction at point A is Ra and reaction at point B is Rb, and the concentrated bending moment is M0 at a distance A, and length of the beam is L. So if we apply the equation of statics, then what we will get? Ra plus Rb is 0 because there is no vertical force. And if we consider, that is, moment about point A is 0, the summation of moment about A is 0, then what we will get? M0 plus RBL is 0. So RB is minus M0 by L. If RB is minus M0 by L, then RA will be M0 by L. So minus means direction is opposite. So reaction forces are here M0 by L, and at B that is also M0 by L, but direction is opposite because that is in minus sign, and here M0. Now we have to take a section at X. Say this is the X, and here the limit of X is here X greater than 0 less than A. Then the section will be like this: M0 by L. Shear force is Vx and bending moment is Mx, and this distance is X. This is point A, and say this is C, this point is C. So Vx minus M0 by L is 0. That is Vx is M0 by L. And what is Mx? Mx minus M0 by Lx is 0. That is Mx is M0x into L. So this is expression for shear force, and this is the expression for bending moment. Next we have to take another section. Through here. So say this is point D. So this section, the range of X is X greater than A less than L, because at here at, say this is DE, point E at distance A. So at point E there is a discontinuity of load because there is a concentrated moment M0. So we have to take two different sections. So here, now for this range, the free body diagram will be like this. Similarly here, M0 by L, the bending moment here, external moment is M0 at distance A, and this is point D. Shear force is Vx and bending moment is Mx. So what is shear force? Vx minus m0 by L is 0. That is Vx is m0 by L. That is shear force is same. Both the throughout the beam shear force is same. That is m0 by L. Both the limit of x we got the same expression. Now what is mx? mx plus m0 minus m0 L into x is 0. That is mx is m0 x L minus m0. So we got the all the expressions for shear force and bending moment. Now let me write down it in the next page. So for x greater than 0 less than a, Vx is m0 by L and mx is m0 x by L, m0 into x by L. And here for x greater than a less than L, for this range Vx is the same, Vx is m0 by L, whereas mx is m0 xl minus m0, m0 x by L minus m0. Now if we draw the shear force and bending moment diagram, how it will look. So this was the beam here, m0 by L, here m0 by L, and this is the bending moment m0. Now let us draw the shear force and bending moment diagram. This is x and this is, say this is shear force. And Vx is m0 by L throughout the beam, m0 by L throughout the beam. So this value is m0 by L. So this is the shear force diagram. So this is the shear force diagram, SFD. Now what will be the bending moment diagram? Now say this is x and this is my bending moment axis. Now for this range x greater than 0 less than a, mx is m0 x by L. So at x equal to 0, bending moment is 0, x equal to 0. When x equal to a, then bending moment will be m0 a by L. Here m0 a by L, m0 a by L. Now bending moment at, for this expression, bending moment at x equal to a, what will be the value for this part? So mx at x equal to a, what will be the value? m0 a L minus m0. So we have to minus it, that is, say here, that value is m0 a L minus m0. And at x equal to L, what will be the value? mx at x equal to L, that will be m0 minus m0, that is 0. So this curve will go like this. So this is the bending moment diagram. So shear force is constant, and the value is m0 by L, whereas bending moment is 0 at x equal to 0 and increases linearly to m0 a by L. There is a sudden drop of bending moment by an amount m0. So bending moment dropped by which amount? This amount is, this is nothing but m0, because m0 a by L to m0 a minus L. There is a sudden drop, that is discontinuity in bending moment diagram. Then bending moment is further linear by this equation and it becomes 0 at x equal to L. At x equal to L further becomes 0. So this is the bending moment diagram of the bend.